Okay, I wanted to go over the examples from solving word problems by factoring. So, a couple things to keep in mind when you're dealing with word problems. You need to define your variables. You need to translate the equation. Really important about translating. Solve the equation by following the directions from yesterday's notes. Bring everything on one side of the equation. Write it in descending degree order. Have equal to 0 on the other, factor that equation, set each factor that has a variable in it equal to 0, and solve, and then check your answers for reasonableness. For example, if you get an odd answer and you're supposed to have an even, you throw it out, or go back and check your work. So let's go ahead and start. Some of these are going to be easy, and some are going to get harder. The directions, are going to tell us to solve. So first one, the sum of a number and its square is 42. Find the number. Okay, so let's go ahead and analyze what we've got here. And what I see is the word sum, which tells us to add. So we're going to be adding two things. Well, what are we going to be adding? Well, we're going to add a number, so we can call it n, and then we're going to add its square. So its square is going to be n raised to the second power. And we know that the word is means equals, and then we should all know what 42 is. So when I ask you to define a variable, what you're solving for is the number. So that's all I need to define here is what does n represent? It represents a number. Do I need to define what the square of the number is? The answer is no, you do not. You just need to translate that. So it asks me to sum or add together the number and its square, and it will equal 42. So job one, get everything on one side, 0 on the other, and we're going to rewrite the polynomial in descending degree order. So that would give us n squared plus n minus 42 equals 0. So then we go ahead and we play the game. Factors of negative 42 that add to give us positive 1 would be positive 7 and negative 6. So we have n squared minus 6n plus 7n minus 42 equals 0. And then we factor by grouping. First two have an n in common, the second two have a positive 7 in common. So it gives me n times the quantity n minus 6 plus 7 times the quantity n minus 6 equals 0. So we get the common binomial of n minus 6. The coefficients form their own binomial, n plus 7 equals 0. So I'm going to carry on over here. We take each one of those factors that has a variable in it, set it equal to 0, and solve. Going back to our Chapter 3 skills, we're going to go ahead and add 6 to both sides on the first one and subtract 7 from both sides on the second one. That gives us n equals 6 and n equals negative 7. So what we're going to do is see if either of these are contradictory. So we're going to test them out. If I add 6 and its square, does it actually equal 42? And the answer is, it does. So 6 works. If I add negative 7 and its square, which is 49, does that equal 42? And the answer is, yes, it does. So how do I write the answer to a word problem? Remember, variables aren't allowed. So we would say the answer would be 6 or negative 7. I would not use solution set notation because solution set notation is indicating different values for the variable given in the problem. You chose this variable, so you're not going to give it back is the answer. So there you go. 2 possible answers, both are good. All right, let's try another one. find the two consecutive positive, well, that's a key word, even integers whose product is $80. Okay, all right. So I'm looking for, let's see what we got going on here. Find two consecutive positive even integers. Wow, that tells me a lot of information. First off, there's going to be two different numbers. Second, they're going to be consecutive, coming after each other. Next, I only have positive options. Remember the last question, we got a positive answer and a negative answer? This one says, if that happens here, throw out the negative answer. And then it says even, and then it says integers. So that tells me I'm going to be counting every other number to get the even, and I can have no fractions or decimals. So if any fractions or decimals show up, that means I've done something wrong. So how do I define them? Remember we talked about these back in chapter 3. Oops, let me change. The first number is going to be x, and we define it as first number, and you can use the number symbol. And the second number is going to be 2 more than that, because remember our pattern, 2, 4, 6, 8, we're adding 2 every time. Now, I don't have to do anything in my definition to indicate whether this is positive or negative. I wait until I get an answer before I deal with the notion of positive, okay? So then it tells me about whose product. And product means the answer to a multiplication problem. Again, is going to mean equals, and we all know what 80 is. So let's go ahead and translate. So two consecutive positive even integers whose product is 80. So what I'm going to need to do is get everything on one side, 0 on the other, but I also need to get rid of the parentheses. So I'm going to go ahead and distribute, and I get x squared plus 2x equals 80, and then I'm going to subtract 80 from both sides. And we have x squared plus 2x minus 80 equals 0. So there's no GCMF, and it's a trinomial, and it's not a perfect square trinomial. Negative 80 kind of throws that off. And so I'm going to come up with two factors of negative 80 that add to give me positive 2. That's actually not too bad, because it's positive 10 and negative 8. So my trinomial becomes x squared minus 8x plus 10x minus 80 equals 0. And then I go ahead and I'm going to factor by grouping. So this group has an x in common, and this group has a positive 10 in common. So what I get is x times the quantity x plus, minus 8, and then I'm going to get plus 10 is the next guy. And when I factor him out, I get x minus 8. So we get what we want. The x minus 8 is the common binomial, and then the two coefficients form their own binomial. So I'm going to continue up over here. So I'm going to take each factor that contains a variable, set it equal to 0, and solve. And here we're going to add 8 to both sides. Here we're going to subtract 10 from both sides. So this gives me x equals 8 and x equals negative 10. Now remember, let's go back to that key word. Let's use this one right here. Positive. Negative 10 is not positive, so I'm going to throw him out. So he's not going to be my answer. But what I am going to do is plug into my two definitions. So the first number is the 8, and the second number is what I get when I add 2 to it, which is 10. And that would be my answer. Now, remember we talked about this in class the other day. When your quadratic coefficient, the x squared's coefficient is 1, look at your factors that are in the game, and look how they show up in the factors the binomial factors. So if you understand that relationship, you can skip from the game to x minus 8 times quantity x plus 10 equals 0 and go from there. Okay, all right, let's try another one. We have the sum, of the squares of two consecutive integers is 41. Find the integers. So this problem tells me, sum says you're going to be adding. And what are you going to be adding? And this is where it gets a little tricky. It's not just two numbers, but the squares of two numbers. So that means we're going to raise these two numbers both to the second power. What numbers are we raising? Well, we're raising two consecutive integers. So these are one right after the other. We know is means equals, and we recognize what 41 is. So when we define consecutive integers, odd, even, doesn't matter, we always start with x as the first number. Second number is going to be one more than that. Now their squares say raised to the second power each of them. Sum says to add those squares together. All right, so this one poses more of an issue in terms of solving. We're going to have to expand x plus 1 times x plus 1. And we go ahead and I'm going to use double distribution. So x times x is x squared. X times 1 is positive x. 1 times x is x. And 1 times 1 is 1. Next, I want to get everything on one side, 0 on the other, so I'm going to subtract that 41 from both sides. So combining up like terms, I have an x squared and an x squared for a total of 2x squared. I have an x and an x for a total of 2x. And I have a 1 take away 41, so that's a negative 40 equals 0. So for the first time, we actually have a GCMF. And that would be 2. So I'm going to factor him out, leaving behind x squared plus x minus 20. So I'm going to go ahead and continue the problem over here. And what we're going to do is play, well, we'll do a little bit here. We're going to play the game. Factors of negative 20 that add to give me 1 are going to be positive 5 and negative 4. So what I end up with is 2 times the quantity, x plus 5, x minus 4. So what I'm doing right now is that shortcut. This is what I get when I would replace x with 5x and negative 4x and factor by grouping. So I'm showing you how I can apply that shortcut idea. Now again, this only works because the trinomial that I'm factoring and playing the game with has a quadratic coefficient of 1. So now I'm going to take any factor that contains a variable and set it equal to 0. And the reason why I can only deal with that, because if I set 2 equal to 0, that's not ever going to be true, so I just throw it out. So then I go ahead and solve. I'm going to subtract 5 from both sides on this one, add 4 to both sides on this one, and I get x equals negative 5, and I get x equals positive 4. So I look back at the problem and see if there's anything that deals with signs. And it doesn't say anything, it just says consecutive integers. So what I'm going to have to do is I have 2 sets of correct answers. Set 1, plug into my definitions, x would be negative 5, and x plus 1, negative 5 plus 1 is negative 4. So that's one solution. Or the other solution, plug in 4 into those definitions. So x would be 4, and 4 plus 1 is 5. So both sets of answers are valid, and there you go. All right, next one. It asks us to find two integers whose sum is 13 and whose squares total 89. Oops. All right, so this one gets a little strange. So we've got two integers, and they tell us that they sum or add up to 13. Okay, so that means I would have two different variables. But the problem is we're not sophisticated enough to do two different variables. So let's deal with that first phrase, two integers whose sum is 13. So let's let x represent the first number. In order to figure out what the second number is, let's let it temporarily be represented by y. And we know the sum of those two integers is 13. If I want to figure out a way to describe y without using a new variable, then what I'm going to do is solve this problem to get y alone. And what we get is y. Oops, sorry. Y equals 13 minus x. And this goes back to something I've been talking to you guys about since probably chapter 2, chapter 3. When you have two unknowns and you know the total, which is another way for saying sum, one number gets to be x, the other gets to be total minus x. So there's proof how you get that. So this 13 minus x is going to represent the second number. So I'm going to circle up our two definitions. And this is what I'm going to use in the next part. So then the next part talks about their squares. And total is two things. Total means to equal, but total also means to add. So when I translate my equation, I get x squared plus the quantity 13 minus x squared equals 89. So I'm going to go ahead and do the same thing we did before. I'm going to expand 13 minus x squared to 13 minus x times 13 minus x. And then I'm going to go ahead and do double distribution. So 13 times 13 is 169. 13 times negative x is negative 13x. Negative x times 13 is negative 13x. And negative x times negative x is positive x squared. All of that equals 89. So I'm going to go ahead and subtract 89 from both sides. I'm going to line him up where he needs to go. And then I'm going to combine up like terms. So I do have an x squared and an x squared. So that's a total of 2x squareds. I have 13x, negative 13x, and negative 13x, which gives me a total of negative 26x. And then last but not least, I'm going to subtract 89 from 169, which is going to give me a positive 80 total. All of that equals 0. So I'm going to do this problem over here. And again, we end up having a GCMF in this problem. of 2. So when we factor out the 2, we get x squared minus 13x plus 40 equals 0. So we're going to play the game with that trinomial, factors of 40 that add to give me negative 13. That's going to be negative 8 and negative 5. So I'm going to go back and do this the old way. So we have x squared minus 8x minus 5x plus 40 equals 0. And the first two, we can pull out an x. The second two, we have to pull out a negative 5. So we get 2 times the quantity x times x minus 8 minus 5 times the quantity positive x negative 8. All of that equal to 0. That gives me x minus 8 is the common binomial, and x minus 5 is the second binomial. So I take each factor that contains the variable, and I set it equal to 0. Oops, sorry. So we're going to add 8 to both sides on this one, add 5 to both sides on this one. And I get x equals 8, and I get x equals 5. So I just need to kind of test them out. 8 plus 5 equals 13. 5 plus 8 equals 13. So it works both ways. Now 8 squared is 64. 5 squared is 25. 64 and 25 is 89. And it doesn't matter if I have 25 plus 64, I still get 89. So my answers are 8 and 5. Because remember, I needed to come up with 2 answers. Okay? Couple more. The length of a rectangle is 4 centimeters greater than its width the area of the rectangle is 96 squared centimeters. Find the dimensions of the rectangle. All right, so when I'm defining variables, and I look at the sentence that talks about the 2 unknowns, and here we are, dimensions of a rectangle or length or width. So where I'm going to look is at the end of that sentence. Because they mention width last, width is going to be my unknown. So that's how I start with defining. W represents the width. To get the length, I read the sentence from the beginning, and it says the length is 4 centimeters greater than. Remember what greater than means. It means more, or in operations, plus. So if I take the width and I add to it 4, that's going to represent the length. Next thing it starts talking about is the area. And the area is a formula that we're going to use. And that's how we're going to get our equation, is from the formula. And remember what that formula is for area of a rectangle. Area equals length times width, or length times width equals area. Either one is fine. Now this one mentions what the area actually is. It says this is the area. Okay, so our equation is going to be length times width, width times length, doesn't matter. Commutative property allows that. gives us an area of 96. So we're going to distribute, and we get w squared plus 4w equals 96, and then we're going to subtract 96 from both sides. Then we're going to go ahead and play the game. Factors of negative 96 that add to give 4 are going to be positive 12 and negative 8. So if you remember the shortcut, because my quadratic coefficient is only 1, then I can say I have 12, w plus 12, w minus 8 equals 0. So this really does save us time. So we're going to take each of those and set them equal to 0 and solve. Sorry. So on this one, we would subtract 12 from both sides. Here we would add 8 to both sides. The two answers we get are w equals negative 12 and w equals positive 8. So then we look at these answers and ask ourselves, is it possible to get a width that's negative? And the answer is no, it is not. So we throw that answer out, which makes the width 8, and then to figure out the length, we plug it into the definition. So when I write my answer, I write width, not w. Width equals 8, label is centimeters. Length is 4 more than that, and 8 plus 4 is 12 centimeters. And that's your answer to this problem. Now I'm going to go ahead and stop this video, and then I'm going to do a second part with the last two, and you're going to want to come back and check that out. All right, see you in a minute.